There we go. But yeah, feel free to start.
Cool beans. I'll just start. I'll just talk, and if anybody has any questions, just pipe in, or keep them to the end, whichever you prefer. I'm here today to talk to you all about OpenStreetMap. My name's Chris Daley. I prefer they, them. I know some of you, I know most of you actually, but what I'm wanting to talk about today is the OpenStreetMap project, what it is, how we use it, and what you can do to help both the OpenStreetMap project and the project that I'm working on with Zash and Getty and Michelle as well, which I'll briefly describe as we go on. So what is OpenStreetMap? Audience participation time. Who here has heard of OpenStreetMap before? That's, other than me mentioning it in class. That's not bad. So who here has used Facebook, Uber, Lyft, Grindr, Tinder? I'm sure there's a whole bunch of others. Yeah, well, if you've used those apps, you've used OpenStreetMap. Because OpenStreetMap is an open source map of the world, all entirely volunteer contributed, crowdsourced from various online groups and individuals, and it's free and completely free, as in beer, but also free as in speech. It's entirely open source, uses the open source database ODPL license, I believe, which means that you can take this data, you can use this data in any way that you want, whether it's to make money, whether it's to run a non-profit, whether to deliver services to homeless people, or whether it's to run a commercial application for pizza deliveries. It doesn't matter. You can use it freely without having to pay any licensing or making any contribution, with the only requirement being that you have to give credit to OpenStreetMap. So this makes it a very attractive alternative to a lot of businesses, but also a lot of organizations as a source of geographic information, because it doesn't have anywhere near the strings attached that you might have from using from a commercial vendor such as Google, or even one of the other ones such as Esri, and I'm trying to think of some of the others, but there's that come to me. But quite a number of vendors of geographic data where you can buy the data sets from and then use, but you have to pay.
Atlas, TomTom,
Yeah. So you buy that data, and it also comes with restrictions for what you can do with it. It may come meaning that with licenses that say you can only use it for analysis, you can't use it for displaying on the internet, for example. So that's basically what OpenStreetMap is. It started well over 13 or 14, maybe even 15 years ago. I'm a little shaky on the history myself. Started in a bar by a bunch of geeks in the UK, in Oxford, I believe. And the idea was to crowdsource a map of the world. And it sounds like a fairly lofty ambition. It's often been called the Wikipedia of maps, based on a very similar approach to getting to crowdsourcing, to user editing. And it's been enormously successful, and even more successful than I thought, given the number of people who'd actually heard about it beforehand. But that's basically what OpenStreetMap is. But is it? There's a couple of questions. Is it any good for what it's used for? So one of the things I thought I'd first do is have a little comparison between OpenStreetMap, a little shootout between OpenStreetMap and Google Maps. And this is you might be familiar already with the Evergreen campus shown here on OpenStreetMap in the beautiful part of the Northern Olympic, I don't know what this area here is called. When we looked at with that compared to Google Maps, you can see that there's almost nowhere near the same level of data and detail. It has the points for where some of the buildings are, and you can sort of see some of the buildings as you zoom right in, but it doesn't have anywhere near the level of detail and coverage that OpenStreetMap does. That's in the United States, and that's in an area that's already well covered by a lot of traditional map data. But when you start to get out into areas such as, and this is the, come back. Let's say, for example, or I don't know, Benin. Oops. directions. No, it's always a little harder to.
There are no available buses at this time.
Yeah.
Yeah. Oh, maybe the map is like.
Maybe the map is there and it's just.
Oh, sorry, it is there. Yeah, maybe,
Yes.
maybe I'm not seeing it.
Yeah.
Maybe it was just so. Then in a country in Western Africa, I didn't actually check this before with Google, but Google data, you know, it's a lot better than it used to be. Where did the search go? This is going to be the one that proves me wrong, isn't it? I was looking at an area around here before. And so this is the level of detail that we have.
Wow.
Compared to that for Google. So you can see that there's, even in places like Bokosa, Benin, OpenStreetMap has a fairly clear advantage in terms of the level of detail that it's capturing in the map. And all of this is a crowdsourced volunteer effort driven by the OpenStreetMap Foundation, as I said, with their principal mission to create a free map of the world, done entirely by volunteers. Not entirely by volunteers, as I'll explain a little bit later, but done entirely on a voluntary contribution basis, that there's been no, it's contributed freely to the OpenStreetMap database, and that data then becomes freely available and open source to the general public. So that's a quick sort of, you can play a game with Google Shootout for hours. It's kind of a bit of a thing people do at OpenStreetMap conferences, but like, and you can search for a lot of locations around the world, and you'll find this level of detail available on OpenStreetMap that you wouldn't expect. Now, in a lot of this is kind of an extreme example, which is sort of why I chose it, because the reason why Google and other map coverage, data sources have coverage of a given area is because usually there's a commercial reason behind it. Like, for example, geographic data about San Francisco public transport and road networks is very useful and valuable data, whereas Bokosa in Benin, it's not quite such a commercial advantage. There are not so many pizza delivery apps available for downtown Bokosa or or one of the other many other sort of or Uber or Lyft, although maybe not far away. But one of the main reasons why the street map data is as good as it is twofold. One of which is there is a large commercial effort to put data into OpenStreetMap. Some of that's from corporations like Uber and Lyft that are paying people to add to the map because it makes commercial sense for them. And there's also imports from government database or government data sets. A lot of the United States road infrastructure, for example, was imported directly from the office, I keep forgetting the United States Geographic Office, the USGS, donated those data sets in a compatible license that could be uploaded to OpenStreetMap. Whereas examples like this are largely driven by the usage of OpenStreetMap in a project run by the OpenStreetMap Foundation, but also by several humanitarian aid organizations, such as Doctors Without Borders and the Red Cross, which is a project that they call Missing Maps, which is, I've got the website up here, is a project about putting the world's vulnerable people on the map, as it says on the website. And this is a project to map those areas in the world where the people are vastly underrepresented and underserved by geographic data, and in particularly with a focus on in the areas where these organisations are working. So, for example, during the Ebola outbreak in 2016, the Missing Maps project was able to map virtually all of the villages that were affected by Ebola down to the level of huts, individual huts, within the space of 3 or 4 weeks. And then that data could be used by those aid agencies that were responding to the Ebola crisis to do all their logistics and medical planning in order to reach the most number of people that they could, that were affected by the outbreak. And so the Missing Maps project is one of the projects that has particularly helped enormously in getting the amount of mapping data that we see in countries like Benin on the map, so to speak. And this is a connection, of course, a little connection with my own personal experience with OpenStreetMap. I guess I should have done the conflict of interest disclosure first, but I have to confess that my wife is the chairperson of the OpenStreetMap Foundation. Full disclosure, but I actually started using OpenStreetMap about 3 or 4 years, what was it, 2013, 3 years before I met my wife. And you know, it was a good topic of conversation for our first couple of dates. But I actually came across OpenStreetMap in 2010 when I was deployed to Malawi as part of a Doctors Without Borders emergency mission during a measles outbreak in the country. And our mission was pretty simple. We had about a little under 2 months in order to vaccinate 2.5 million children against measles in a country which is, I don't know if people know much about Malawi, but it's a fairly rural country. A lot of the population lives outside of the big cities in small villages. There's very little of any sort of infrastructure outside of the main cities in regards to water or electricity. And so there's a number of significant logistical challenges, not the least of which was what we call cold chain, which was is about keeping the vaccines at a stable temperature between -5 and 2 degrees centigrade was what we strove for. And keeping them at that temperature range during the entire use from when they arrived in the country to when we injected them in the arms of the kiddies. I don't know if there's anybody here who's opposed to measles vaccination, but I guess I was saying this would make me the Johnny Appleseed of autism, right? But one of the main things or one of the really key principles whenever you're doing a mass vaccination campaign for a disease like measles or any mass vaccination campaign where you're aiming to increase what they call herd immunity, which is the immunity to and resilience against the disease throughout the population, is you want to get the largest possible coverage that you can. You want to get as close to 100% vaccination coverage throughout the entire population, which in a country like Malawi was proving to be quite difficult. One of my jobs was going out and surveying the communities to get a sense of their population and how many children they had and where we could set up the vaccination areas. And the information I had to go off when I first arrived in northern Malawi was almost nothing. There was handwritten lists of village names with rough directions on how to get there, pages and pages of these things scrolled almost indecipherably, and and Google Maps, which at the time was nothing, almost nothing. And I don't think it's much better. I can pull it up in a minute, but so you know, we were out doing the surveys, and in the process of doing the surveys, I realized that there were many, many more people and many more villages than we had any information about whatsoever. And so I was looking online on the internet at 1200 baud modem that I could get with my 2G, I think, connection. And I found talk of this OpenStreetMap. And I looked into it further, and I found an OpenStreetMap data set, or a data set that had been extracted from OpenStreetMap, that had been created by four-wheel drive enthusiasts from Johannesburg of northern Malawi, which added an extra 200 villages to the list of villages that we had already, and gave us precise coordinates for them, and even had paths that tracks that they'd made showing the roads to get to those places. And we added, we estimate an extra, I think it was an extra 10,000 children alone just in that area that we were working on, thanks to the OpenStreetMap data. And that it was there. It was like we had during that time, during the period where I was looking for it, we also managed to get old British survey core maps of the area from the 1960s, and there were villages marked on these an OpenStreetMap that weren't marked on these maps. Like I said, there was almost an extra 200. So it made quite a significant difference to our ability to plan, to ensure that we had the highest level of coverage, to know where to send the teams, and it was fantastic, and it was completely no strings attached. The data was available in any format that we wanted to use it in and throw it around in, and it helped us really achieve our ultimate mission of where we vaccinated 2.5 million children for about 2.8 million euros. That's efficient. We're pretty pleased with that. We got some good bang for the buck out of that. But that was my first introduction to OpenStreetMap, and I was kind of hooked on it since after that point. I was like, wow, this is actually like, my first thoughts going into it, I was like, how can a crowdsourced map of the world actually be that, provide that much information? It takes a lot of effort to map. I'd learned basic cartography skills in the Australian military, so I knew the actual principles involved in surveying and mapping, even from satellite imagery, is time consuming. And yet here it was, this phenomenal mapping data source that had coverage that even the monolithic Google couldn't achieve. And in part, and it is largely in part due to its open nature, that anybody can edit the map. Literally anybody, well, not anybody, but anybody who can fulfill a few basic requirements, namely one of which is to be able to log into OpenStreetMap is probably about the only real requirement. And I'm going to do that now. This is going to be the workshopy part of the presentation, where I'm going to go through how you actually edit the map in OpenStreetMap, because this is probably the most interesting part for some people. But when you come to OpenStreetMap, this is the website as you see it. It has a login button, which is kind of mandatory before you edit the map. And if you don't have a login, there's a sign up. Sign up lets you either create an account, or the alternative is that you can go through login, and this is the important part. It actually lets you use a third-party single sign-on provider to log in. Rather than having to create a whole new account with a password, you can just log in using Google, Facebook, your Windows Live password, GitHub, any one of those services. Seriously. Well, it's there. And you can just log in using one of these services. So you don't have to worry about another password to remember. And then it's like, of course, you have to remember which account you set it up with.
Can I ask a question?
Yeah.
I'm just really curious. Can you answer really, if you know off the top of your head, why does it ask country of residence, France, Italy, and then rest of the world? Is there a significance to those two countries?
I would be talking out of school if I said what I thought it meant, but
okay.
I don't know. I haven't seen that one before. Is that when you go to the sign up?
Yeah.
I just wonder if that's a.
It just asks you like, what's your country before it gives you the terms. Oh, maybe it's the terms change.
Yeah.
It just changes the language. Wow, that's okay.
Yeah. I mean, also, I was wondering if that was just something to do with the GDPR. The recent European law on privacy?
Yeah, maybe.
Possibly, because my wife spent a lot of late night meetings arguing with French and Italian people about it, which is why I was wondering if they were like insisting on their own. That is a funny thing. OpenStreetMap can be it's a weird phenomena of this type of crowdsourced geography is that on one hand, while it can be so amazingly globally unifying, that you find that you're part of this enormous community that is working on this project to build a better map, to do all these better, to make the world a better place. And then people have these incredibly petty squabbles over, whether it's got, a tilde over the end of a word, or if the name of the place has two B's or one B in it, or if you use the French or the English term for it. So in a way, it's humanity. But anyway, so I've logged in now, and you can see I've got my little moniker up the top. But the important thing now is that once you've logged in and you have this screen, the edit button will now actually do something rather than ask you to log in. And that's up in the top left corner. There's three options which are listed. You don't really need to know much about these unless you're wanting to use an external editor, which is like a piece of software to interface with it rather than working in the browser. We're only going to really cover the browser now, and that's the default option, which is Edit with ID, which is the in-browser editor, and that's what you get. That's what you get if you click on just Edit by itself. And then the interface doesn't really change that much while it's loading. What it does do is it brings up background map. Background satellite photography for which to use to trace over the top of to create the maps. There's a couple of different options for the background settings.
Yeah, what is Mapbox's role at the lower left of this?
Sorry, with the lower left.
Oh, I see.
Oh yeah, Mapbox.
Mapbox.
So this is there's. So first, in that particular instance, there's several layers. I was going to go through everything step by step.
Thanks.
But there's you can choose from the type of background, which is the type of satellite imagery that you're going to use to trace over the top of. And there's a number of different options in here, including Esri is donating some of their world imagery. But these are the providers, these are the companies that have donated their satellite photography, which is not cheap. If you can imagine how much it costs to put a rocket into space, it's not as cheap to take a photograph of the Earth as it is of your face for Instagram or your dinner. And so, this is a large part of what's helped make this project successful. Has been these companies donating their incredibly valuable satellite data to be used for this project. Because believe it or not, actually tracing over the top of a photograph, if you don't have permission to do that, you're actually in breach of copyright law. Because even though you think you're just tracing, which is basically what you're doing, the actual data that's encoded in the satellite photography is under the same royalties or the same rights as if it were any sort of photograph. But it's also considered data for this purpose. So you can't actually trace over the top of Google Maps, Google Earth, for example, because Google doesn't want OpenStreetMap to be competing with it. So they clearly haven't. You don't see Google up here. But these are the providers that have agreed to donate their satellite imagery. The example that I'll go to is back to Evergreen, because I feel okay about editing Evergreen and maybe not so much about downtown Benin. Such weird way. And so you can see here, this is the map of Evergreen, now in the edit mode. And I'll just explain a few things about the interface before I sort of go into any other sort of details, which is I kind of jumped in without actually asking people much how they knew much about GIS before we got started. But most GIS, Geographic Information Systems, So like if you say GIS systems, is that a tautology, or what's the word for that? Redundancy. But GIS systems work using concepts that OpenStreetMap calls them ways, but it's basically lines, and that's collections of lines. So lines that go from one point to another, such as say the roads that you can see going around. They're what's called in OpenStreetMap, or in most GIS systems, are like a line string. So it's just dots, points along the map that are made that connect lines to lines all together in like a string. And they're straight lines too. There's no curved lines. So you make a curve by lots of tiny little straight lines all adding up to a curve. So that's a line string. The other type is polygons, which are enclosed. So they're basically line strings that you've all joined up together to make like a square. And they're used often for things like buildings, which or for like marking out like a football field. And they're a closed and filled in solid square. So that's why polygons are usually used for outlining buildings, but you can also use them for like things like outlining like a forested area, or anything that's in an enclosed. What am I thinking of? The height lines, the topographical lines can be outlined as a polygon as well. And they're the main data types that OpenStreetMap works with, and it represents them as these like open lines that you can see. And I'll zoom in a little bit closer if I can on the buildings here, and you can sort of see and these are the outlines that form the buildings. And so when you click on one of these outlines, whether it's like the paths or a polygon, you can see that these are the different points that I was mentioning before. Each one of these is a point that is recorded in the data set with an X, Y, and Z coordinates, which correspond to the geographic coordinates of the actual physical item on the Earth's plane. I'm not going to go into coordinate systems too much, because that's a fairly major topic. But this uses I think it's the WGS84, which is like the Web Mercator standard, for displaying and projecting the image. But you don't really need to know too much about that, other than that each point represents a point on the Earth's surface. And in terms of polygons for buildings, they're all joined together to form a whole solid. And for the lines that form up the paths, there's basically just a line or a line that is completely open. And to edit them is super. Oh, sorry, the third type as well. I forgot that there is a third type, which is the one that you'll see the most in a lot of mapping applications, which is where it's a point, or often called a point of interest or a POI. But they're not necessarily the point is not necessarily a POI, but they're usually used to represent points of interest. And these are just it's just a simple single dot, one XY coordinate, and that is can be used to represent basically anything. It can be used to say that it's a building, and that's like the center of where the building's coordinates would be. Or it can be used to denote something about a building, like say the campus police are located here in this building. And those are the three general types that OpenStreetMap works with. So the interesting bit, which is how to add and edit them, is pretty simple. So to edit, you'll see that when you're in the edit mode and you move the mouse over it and you click on like a polygon, you'll see the circles come up, and you can just move the polygon around and change the shape of the square. So that's basically it's as simple as that. I mean, it's simple to me. It's probably not necessarily simple to everyone. But when you click on a point, undo it. Why isn't it doing it? Try on a. So they changed the interface since I used it last, which wasn't as that long ago. But
And clicking the save button up top there will automatically update this inside the.
yeah, so when you click on the save button, so you'll see when you start making changes, you'll see a couple of things happen. One is that the save button becomes active, and you also see that this arrow here becomes active as well, and that's the undo. So you can actually just undo any of your edits at any time if you make a mistake. Save lets you save the changes you've made, and in this case, it'll actually, because the way that OpenStreetMap is structured, it works in a very similar way to like a code versioning system, where you can have multiple versions of code side by side, or you have change sets like a diff and patches. And it works very much in this way. So each time you make a change, rather than saving the entire map all over again, it just saves the changes that you've made to the map. And it usually gets you to write in a description of what you're doing. So there is this log of what the edits are made over time as well. And it's usually good practice to fill in some comments about the edit that you made, whether it was that you made the edit because the building has a new part of the building, or the existing tracing of it was inaccurate. You would put that into the comments that you make, and then you click on the upload, and then it's uploaded and automatically changes the data on the website on OpenStreetMap. It might not be visible immediately because of the way that the internet works, and where it's the internet, the way the servers operate for more efficiency. They'll cache all of the tiles so that they're not constantly having to regenerate for every single one of the millions and millions of people using it. So it may take a few minutes for that data, or seconds to minutes, for that data to be reflected for everybody else who's using OpenStreetMap. But for you, it'll be changed straight away.
We're just checking for our RA. Kiwi's not in here, so.
Well, we'll cancel those changes because we didn't really do anything. The other thing to point out when you click on any one of the features, whether it's a way or a polygon, or clicking on one of the points, is that it brings up over in the left here the data fields that are associated with the point or the polygon or the line string. And this is a really crucial part, and this is actually one of the key strengths or power, the real power of OpenStreetMap, is that these fields that you see here are I guess you say the default fields, but there's no limitations on what fields any data point in OpenStreetMap can have. It can have unlimited number of fields of just about any type that you can conceive of, all saved as strings. So like those of us who've been following along the difference between integers and strings and whatever, they're all saved as string values, but because of the nature of the database, but they're saved in what are known in the game as a key value pair. So you have the key, much like we have with the Python dictionaries, and that's like the name, the operator, address, and then the value is what's entered into there. So the database, when you add new fields, it just adds a pair, which is the name of the field and the value, and you can add, as I said, any number of fields, not just data, but fields to a particular data, to a particular point or line string or anything. And it's so you can add. You see here, it's already like, for example, it's got the tag amenity, and in this particular case, the amenity is police. I'm not sure. I don't consider them an amenity myself, but I guess that's the. But you can see that, like, in addition to police, it could be a bench or a restaurant or a place of worship, a school. There's a whole bunch of already selected options, but you're actually free to add anything in there yourself as well, as long as it's a text string that can be repeated. The other thing as well is that, and I might find an option, but the issue of what you actually call something in a given language, it's usually not a problem here in the United States so much because of the force de jure of English as the everyday language, although Spanish is coming in a fast second. But in some countries, it's actually mandated by law that maps have to be in multiple languages, such as like in Spain, for example. The maps in Catalonia need to be in Catalan and in Castilian Spanish. In the Basque country, they have to be in Euskera and in Castilian Spanish. So OpenStreetMap actually allows you to assign a name in any language for that feature as part of the feature details. You don't see it, it's not here in this one, but we can look and I won't slow down now, but it allows you to add a language, and not just like the language for the name of the tag, but you can add any of this information in an alternative language, and any number of alternative languages as well, so that you can make your geographic features accessible not just to people through the internet, but also through the internet, not just visually, but also linguistically. They can search for the names of place marks in their native language, and that includes any writing script that can be represented in UTF-8, so Unicode. So it can represent Unicode languages, so that's like the Cyrillic languages, but also Chinese, or one of the various or Chinese scripts, or the Japanese scripts can all be represented, not just in the fields here, but also rendered in that way on the map. So the names of these will be in multiple languages. And in fact, why don't we go to and so so there you'll see like this is the example of that. You've got this is Tokyo. So the primary name of Tokyo, because it's the capital of Japan, right, is represented in kanji as Tokyo, not in English, because that's the name of the city, not Tokyo. Well, it is Tokyo, but that's not how it's written. So in this case, and this is why I like this as an example, you can see all of the other names that it's known for on the map as well. So there's somebody's bothered to put Asturian Spanish translation of like Tokyo. It's a pretty obscure language. There's like 500 speakers of it or something. But you can see there's an Arabic there in the native language of the country. So that's one of the other most powerful facets of it, is you can add in the name of the place in its actual language, and depending on in this case, so if there is an English name, because English is the language set in my browser, it will display those names in English, as well as in so yeah. Well, actually, in the map renderer, it renders them all entirely in kanji. But because that's the language of the country. But the power of it, as you saw in the edit, that data representing how those places are represented is available in a whole bunch of other different languages. So the important thing, and I think it's a good time to point this out as well, is that OpenStreetMap is not the website. The website is a means of viewing and editing the data, which is what OpenStreetMap actually is. It's a collection of key value pairs that are geo-referenced to a physical location on the Earth's surface. So what you see here when you're looking at this is a particular renderer. And this renderer is the OpenStreetMap website renderer. Whereas the apps that you might download for viewing OpenStreetMap on your phone will use a different renderer. And the settings of those renderers will determine how things are stylishly, how the style or how they appear, so the color of the roads, whether it's so many dashes for a path, or what the style of how the map is displayed, but also what language is used in displaying that data. But so to continue along, just to like sort of try and move closer to the end of it, is the other that we looked at how you can edit and change a feature on the map. So like, for example, that's the same with like, let's make the freeway here like take a detour. Why is it not doing that? So we've made the map take a rather terrible detour. So there's just the direct editing of manipulating the little dots here. And then there's also the modification of the tags, the key value pairs here inside. So that's how you edit any type of feature, whether it's a polygon or what they call the area, or whether it's a line or whether it's a point. And if you want to add a new one, for example, you want to add a new point, all you have to do is click on the three buttons above here, and this will give you tools for drawing those new shape, whether it's a point or a shape. And so you just click on it somewhere in the map, brings up with the pointer. It allows you to select the type of feature that it is. So in this case, we might say that it's a park, and then it would give us the opportunity to add a name. But also, as I said, there's a whole bunch of these other tags that we can add down here as well. Add like a source, so like give a credit to a particular source, etc. There's the tags go on and on and on. The tags aren't all just contrived at random, although that's how it kind of happened to begin with. People just started adding their own tags in left, right, and center. And at a certain point when everything started getting really out of control, some very, how shall we say, neat freaks got involved and straightened out what the tag structure should be. So there is an entire wiki on the OpenStreetMap website which goes into detail about just about every single tag that you can conceive of. So you should check there before you make up your own tag, is basically it. But if you can't find your own tag, you can still go ahead and make your own. And that's, again, one of the really powerful parts of OpenStreetMap. The other tools, like area, work kind of as you might expect that they would. You click points and you like draw. And the difference is that, so now you double click to close the area, and then that's now a closed polygon. So that would then be, and it gives you the options over here on the left, you can choose from a bunch of different features. And so in this case, it could be a building. So it gives you a bunch of different building options, building, house, apartments. So as you can see, that there's a few defaults here already set up for you, so you don't have to think about it too much. And then you can get into adding all the details if it has a name. For the project that we're going to be working on, a really important detail, the number of building levels, so that it can store because you have this flexibility of the key value pairs, you can store data about the building that's not just the outline of the building on the ground, but also about what's inside the building. So for the project that I'm working on with Zach and Eddie and Michelle here, we'll be using OpenStreetMap to map out the insides of the buildings just as much as we will be of the outsides. So, and we do that through the power of the key value pairs by assigning, when you do a building, one of the tags that it will have automatically will be to say building, yes. When doing the rooms, you add the tag building part and then room, and then that tells us that that's a room within the building. And then the only other final one, which is the lines, lines are usually used for like drawing paths or roads, as we saw. And the difference is when you're finished and you double click on the last point, it doesn't close the shape in like it does with the polygon. So you're left with like a path. And then because paths are usually used for, or the lines are usually used for drawing things like paths and roads, it actually defaults to giving you the options of the various road features. So you can have a motorway stretch running through. And again, and it comes with all of these incredibly useful tags suggesting like where you can put in the speed limit or the number of lanes that are in the on the road or the type of structure it has. It has a bridge. And while it might seem that some of this data is just for people who are like completeness nuts, you know, the people who have to fill in every form or who know all of the statistics for all the World Series matches, this data is actually insanely useful for doing things like routing. So when you're when you use Google Maps and you ask it to take you from one location to another, it's using what they call routing. So it's routing you from one point to another on the map using the data about the types of roads that you can use to get there. And so the way it decides which is the best route for you, or route, comes down from a number of variables, including it might be like what the speed limit is, what the type of road it is, you know, whether it's one way or not. That's an important detail that it needs to know. And this is where the routing engine, or there's several routing engines that use OpenStreetMap. This is where they get the data that they use to complete that, or to do that, is in these types of fields that you should really try to answer and put the data in if you're going to add something like a new road or a new building. Try to be as complete as you can, because that makes the data all the more useful. And that's really it for adding and editing structures. I mean, the thing that is, it's very much like Wikipedia in that sense of you can just dive in and do it. Right? There's not going to be somebody who's going to like have to check it before it goes live. You know, you don't have to like pass some initiation ritual or have a GIS operator certificate. There's no barrier to entry other than being able to create a login for OpenStreetMap. So in some ways it's kind of a bit radical as well. Some people find it a little weird at first that there's this awesome power to do this thing and nobody's going to like stop them from doing it. Which is why they've recently added, and believe it or not, this has been feedback, which is that some people would actually like somebody to review their edits once they're made, because people feel like they maybe haven't done, you know, like as accurate a job. They're beginners, they're just beginning, so they want somebody who's an expert to review it. And so what will happen is that those edits that you make, those changes will go live, but one of the people who's listed as like a reviewer will get a message saying that you want them to review those edits, and they will get the message about what edits you made, and they can go and double check them for you just to make sure that they're as, you know, perfectly accurate or you've done a good job. And this was added because there are now a lot of faculties using OpenStreetMap as well to introduce particularly aerial or cartography. And this is a great way for having a sort of a level of review of it on there for students to get feedback on, you know, how well they're doing at it. It also has like warns you about things like where we've got our wacky little bit of disconnected highway there. And so a lot of this is like nice little quality control mechanisms that are built into the back end of the software. And so that's basically the editing interface in a nutshell. There are some extra features whereby you can upload GPS traces. So if you've got like a GPS that you've got that's been tracking you, or like your Fitbit even, you can actually upload your Fitbit your Fitbit maps to OpenStreetMap. These are mostly useful when you've gone out and you've mapped an area that doesn't have reliable satellite imagery, or like in places like, believe it or not, there are places where it's really hard to get reliable satellite imagery. Like parts of Indonesia where there's almost constant cloud coverage all year round. It's really hard to actually get traceable satellite imagery. So you can go out with a GPS, old school, and track. So as you drive along, it tracks you as you go along that perilous mountain path up to the top of the volcano. And then when you get back alive, you can upload that to OpenStreetMap and then trace along those lines to add that new road accurately from your GPS traces. So, and that was how the map data that I used in Malawi was all uploaded in this way. And so that's OpenStreetMap, the website editor. I did want to give I don't know how people are traveling for time. I know I've been talking for an hour, so I was going to actually wrap up myself for my own for my own sake. But I did just want to give a quick plug to two things. One of which is there's the editor where you see editing here on the website. There's also a really good open source GIS package called QGIS, which if anybody's wanting to get interested in, I think probably have Esri licenses here, students.
Yeah, but there aren't enough students who have used the Esri licenses yet, and part of what I am trying to do is build a little more of a user community. And we have 1,000 ArcGIS online licenses.
Oh, wow.
Where, and 160,000 credits.
Wow.
So we're armed for a lot of that.
So this is a free package, but like certainly the college's ArcInfo and ArcGIS. But this is an alternative to that, and this is if you've ever used like a drawing program like Adobe Illustrator or Corel Draw, then it works in a very similar way. In that, and very similar way to, as we were mentioning, to the OpenStreetMap editor itself. You can just add details on here, but you can import OpenStreetMap data directly into this application itself as well. And the same, I believe you can do with the Arc suite as well. So that you can actually, other than just editing the map online, and which is great, and thank you very much, and we please hope that if anything, somebody goes away and contributes. That helps contribute vastly to the great OpenStreetMap project. But if you have your own project where you don't necessarily need to contribute any changes back, but you want to use geographic data that's available in OpenStreetMap to do like a geographic analysis, like to figure out how many buildings there are in Olympia, rather than sitting there and looking at Google Earth and counting each one of them. You can actually just import the data from OpenStreetMap and then run one of several of the extremely powerful processing. There's several geoprocessing tools that let you combine and modify the data. It also lets you do, under the analysis tools, you can also do a whole bunch of geographics analysis on the data. So like finding out where various boundaries intersect, counting the number of features within a given area. Quite a lot of things you can do within QGIS or any other sort of GIS program using the OpenStreetMap data. And the final bit I wanted to talk about before I wrap up and lose my voice entirely is the big reason why I've decided to do this workshop, other than to extol how wonderful OpenStreetMap is and how you should all contribute to it, is also that we're using it as the baseline data, or integrating it into a project that I mentioned before myself, Getty, Zach as our spiritual and project leader, and Michelle are all collaborating on, which is an indoor localization and navigation tool for blind people. So it's a tool for assisting people who are visually impaired to navigate around initially indoor spaces, but allowing them to independently navigate with just their smartphone and their any other sort of assistance aids that they might have without requiring another person. So as part of that project, we need to build a map of Evergreen, and not just a map of the buildings, which as you could see from when I showed earlier, already exists. But we're hoping to start mapping inside the buildings as well. And so using OpenStreetMap as the repository for that data, hopefully that we can build it up rather than necessarily the small team that we have working on developing the application, rather than us also spending all of our other time that we could be used in developing, also building this map. We're hoping to sort of crowdsource it and get some involvement. So either yourselves, or if you happen to know in your circles people who are interested or looking to contribute to an open source project, but they're not necessarily computer programmers or have sort of highly specialized skills, but they still want to give something back, or in particular if they want to help us achieve our project goals of building a navigation device for people with visual impairments, then put them in touch with us, myself principally, I guess, but or if you know Getty or Michelle or Zach, put them in touch with us, or Richard can also act as a good filter, because we're hoping to get some good mapping done in the next couple of weeks to hopefully build up the data that we need on for our project on OpenStreetMap. And that's basically it. I could keep on talking for hours, obviously. But I'm really grateful that you've all been so patient, sitting through me just talking non-stop for the last hour. And I can shut up and go away now, but I can also answer some questions if you've got any.
Wait, I have a quick question. Like with some of the I know, well, sucks. All right, never mind. I can just ask you later.
It's over.
But that was awesome, dude. The Google Sheet app, full of shit. It's crazy how much more data they have.
Yeah.
Yeah.
And you said this company is used by those big other companies you were talking about?
Well, basically anybody who's not Google now. So you might be using their app, and you might see that when you use their app, they're using Google Maps as part of their app. But the data that they're actually using to do the routing and the navigation and to put the pins on those maps is usually coming from a combination of data sources, including OpenStreetMap.
So I drive for Uber. I've only been doing it for about 6 months. I regretted not picking Google Maps for my navigation on there, because the map that gets used, I don't know if it's Open Maps, it actually it does not zoom out or zoom in very appropriately, like when you're approaching a destination. And it'll take you on detours sometimes, quite a bit more often than Google Maps will.
Interesting.
Yeah.
The zooming problem, I'm not sure, is OpenStreetMaps, but the
right. I don't know what it is. Yeah, right. So like I love this. This is awesome. But yeah, like I was kind of curious. Like, is that due to a glitch like that, which is kind of essentially what it is? It kind of slows down the Uber driver and the Uber passenger. Mm-hmm. Would that be because people are adding their own stuff to it, or is it because there's not enough stuff?
There's not enough stuff. You need to get in and add it.
Yeah.
What's the best app for portable mobile use of OpenStreetMap? If I want to use it for navigation instead of Google Maps.
Yeah. The best one that I've used is certainly, and actually the one that my wife recommends, is maps.me, okay. So maps.me.
I saw that, yeah.
And that one's got the it's got the best routing engine for sure, and it's also the most
possible to edit live within that app if you're on the move somewhere that's new, or is that a bad idea?
You can add. I'm not sure if like the maps.me. There are a couple of online editors. Maps.me lets you add like your own points to it, so you can like make your own notes, and then you can save that, or you can push them back to OpenStreetMap if you think they're useful.
Is it possible to do geocoding with an OpenStreetMap
Yeah.
data set?
Yeah, so there's at least, this is what, so one of the other things with OpenStreetMap is that it's because it is like the foundation just looks after the data set. They're not responsible for the apps or for any of the other things, with the exception of the website. So there's this whole ecosystem of other apps and interfaces. So there's there's at least 2 different routing engines that you can use. Mapbox is a company that's done a lot of building out of that sort of stuff. So they have like tile services and routing services. And there's, for the geocoding, there's Nominatum.
What's it called?
Nominatum.
Nominatum.
Is the and they're an API. More, and I think the Nominatum is a service as well, but that's the one that so when you do a search on the OpenStreetMap website, it'll actually list so there's Nominatum and there's another one where it gets the geocoding from, and it'll list them when it does the search. So everybody else is tapping away now. I'll consider that
thanks,
a,
Chris.
a
That's
job
awesome.
done.
I just bought my car a few months ago, and they already got the imagery updated on here.
You gonna-
Like it's in front of the house that I live in.
Oh, that's
Yeah.